Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be talking about another ensemble technique, another type of ensemble technique, I should say, and it's about stacking. Till so far, I think in my previous discussion, I have shared you the concept of bagging and how it works internally, what's the intuition behind that. And I have demonstrated that with the help of an example of, KNN classifier, right? We have taken one data set, we have loaded it from sklearn.dataset itself. That was a breast cancer based data. And we have seen that how by applying 10 number of estimators as a part of a KNN, we will be able to get the predictions at the end of the day. Now, uh, some people might have confusion that what if Priya, we will try to add different kinds of models and we need to see the variety of the intuitions with respect to the different models that we have in the classifier or regression per se. So can we do that? And if yes, what is the intuition behind that? So today I'll discuss those aspects in the process of stacking. So without wasting any time, now let's get started and we'll try to understand the complete flow behind stacking with its practical implementation. I will try to showcase you. So let's get started. So now what will happen in stacking and how it is different from the bagging algorithm that we have covered up so far. Let's try to understand it step by step. First of all, I will try to showcase you the intuition. Followed by, we will do the live demonstration of the same so that the understanding is very much apt. Okay. Here you can see, right? What is happening is, let's say we will be having the training set available with us. I think this should be the first diagram. I should write it. So this is the step number one. Okay. So let's try to see our journey from here. And let's say we will be having a training set available with us. So what will happen is in the part of a stacking procedure, we usually try to split our data into two components. One is the training set, another one is the validation set. Now, what is the meaning of a validation set? Till so far, in our journey of ML implementations, we have usually tried to split our data into two components, training and testing. But in this stacking part, you will observe that what we are doing is, what I'm saying is, we will try to split our data in a very first step into two components. One I'm saying it as a training set, and another one I'm saying it as a validation set, right? Validation set. Now, what is the intuition behind validation set? It is also called as holdout data. Okay? So whenever you will heard this term, don't get confused. It's just that I don't want, the data to be already seen. So it's kind of a unseen data so that we will be able to get a more actual predictions from our model, right? So what will happen is, we will have, let's say, 100% of a data, right? So we will try to split our data in a 50-50 ratio, where 50% of data will go towards the train set and 50% will go towards the test set. Not test is validation set, I'm saying holdout set. So that is what they're calling it as a subset 1, which is a part of a train set, which we will further split definitely. And it is what we are calling it as a validation set as a part of a subset 2. Okay. Now what they have done is, they have tried to apply the different models that we have on a training set. How? Let's try to understand that aspect. So this is the, you can say this is the step number 2. Step number 2. So what is happening now? What we will do in a validation set, which is the subset number 2 that we have, right? So in the training set, the further split usually happens into the training and testing component. So maybe you are trying to split our data further into train and test, where you are saying 80% I will hold inside the training part and 20% I will hold inside the testing part. Further split can happen. For example, if I'll just give you one demonstration, for example, if you will be having 1000 number of records, it can be any data points you can imagine. What I'm saying is 500 you are taking it as a part of a training and 500 you are taking it a part of a testing or a validation set, holdout set. So what is happening is that this 500 is unseen data, which is not even seen by my model. My model is not aware about this set of data points that we have, which we are labeled as a subset number 2. Now, which the 500 points that we have, almost 80% of this 500. So what does that mean? Like almost you can say 300 data points will be available in the training and almost 200 data points will be available in the testing part per se. So now the training will happen on top of this specific data points, and Here you are applying maybe separate algorithms. Maybe you are applying KNN, you are applying you're applying KNN classifier, you're applying SVC classifier, and let's say you're applying logistic regression classifier. Now, what will happen is from each and every model, you will be able to get some result, right? You will be able to get some result. Now, what we will do in stacking, because first of all, we are using some different algorithms altogether. Now, whatever is the subset number 2 that we have, right, which is a validation set, which you know, right? It's a validation set that we have. So what we are doing here is we are trying to get the predictions on top of this specific set. So what we will do is we will see that how this model is working. So definitely from different 3 models that we have, we will be able to get the 3 predictions, right? My model will be able to predict the final predictions, and that will be taken as the training set further. So this is one of the most crucial point which you have to understand. Whatever be the model predictions we are getting in a stacking, right, that will be a input value. That will be a input value for the another training part per se, which you will do to combine all the predictions. So whatever be the values which you're getting when you're feeding a validation validation set predictions, that you will be taking as the input, and you will apply on top of this some other algorithm. For example, you're applying a random forest algorithm, and now your input feature is entirely different. It is not the original one. It's the predictions that you will be able to gain. And that is what the beauty about this algorithm. So it's like you're merging all the outcomes in one go, and then you're trying to train on top of that. You're combining the predictions, and that is where you will be able to create this blender, right? Which contains the, you can say, predictions of every particular data point that you have. So this is the final thing which I want to showcase. Again, I have taken all these pics from the standard book, which I just in the previous video showcased you, right? What is that book? Hands-on with the machine learning. So what is happening is, let's say whenever a new instance will come, whenever some new data point will come into picture. So what is happening is you will be able to observe that same thing will happen with respect to that data point also. It will go to the prediction part. It will make some predictions. And then this predictions will be the input feature, which will go to that blender. And finally, the final outcome we will be able to achieve. So that is why it is called stacking. There are models one above the another one, right? So we have a list of few models, which you can say is a base model that we have, where we will be having a different algorithms working together. We will get the predictions of that. We will combine those predictions. We'll take it as an input feature for the next model. Maybe we'll combine all these predictions, and we can use some other algorithm now on top of that, maybe random forest classifier, and then we will be able to get the final outcome. So this is how basically the internal working of stacking comes into picture. And why it is called stacking, I think now it is pretty much clear to everyone that we have the base models available, right? We have one base model available where you can say that multiple models are working internally. So here we will be having one base model, where you can see we will be having M1, M2, M3, right? And now whatever be the predictions given by these models, different models that we have, we will combine these predictions, right? All these predictions we will combine, and that we will take it as an input feature. This P1, P2, P3 will be the input feature for the next new model, which we will be able to create, model M4. And by the way, all these models are different. This is something which is the final result which my model will be able to give. So this is the blender by which we are blending all the results, and we are accumulating, combining all the predictions. So this is the overall idea behind the stacking part in machine learning, where we are using a knowledge of different algorithms that we have, combining their predictions to get the final result, final outcome. And that is where it usually achieves a better accuracy also, because now we are not relying with one model itself. We are using the different algorithms, different models all together, and stack all those results in one go. So stack means layer by layer. So we have multiple layers here. So now what I will do is, might be for few people it is somewhat confusing what I'm trying to convey, that how the predictions will become the input features for the next internal model that we have. So what I will do is I will try to showcase you the demonstration of everything, whatever I have showcased you here. So now what we will do is we will try to write step by step each and every line of a code. So what I will do is, let me show you a flow that what is the implementation we're going to do here. We will take our diabetic data, okay? And what I will do is I will apply the stacking algorithm on top of this. By the way, in sklearn, we don't have direct stacking algorithm. You cannot call it. You can just implement it on your own. So I will just showcase you the implementation for the same. So what we will do is we will be having a diabetic data available. Okay. Now what we will be having in that diabetic data, input features are there and target column is there, which is the outcome. So first of all, we will try to split our data into train set and the validation set. So that is the first task which I will do in the implementation. After that, further we will split our data of train into two components, train and test set. And after that, we will do our training of two algorithms here. So what we will do is I will try to take two different M1 and M2. One is, let's say, I'll take KNN, K nearest neighbors, and second I'll take, let's say, SVC. After that, once I will be able to get the results of these two models, once I will be able to fit these two models, I will see the predictions of these models or the score of these models on the validation set first. Validation set first, okay, which I have taken here, right? Here is my validation set. Now, whatever prediction I will be able to get, right? This is P1 and P2. I will pass these two predictions as a parameter for the another algorithm, which I will train as a random forest, RF. And finally, after that, whatever be the results we will be able to achieve are our final predictions. So that is the pipeline which I will try to demonstrate you here. That is the final idea, final outcome. One thing you can ask that, Priya, what we will do with respect to this test set, which is 20% you have taken. You can also, make the predictions on this test set. I'll showcase you each and everything. I will use this test set also when we will do the, score part with respect to the KNN and SVC algorithm. And then when we'll do the final result outcome also with random forest, everything we will do. Okay. So this is the whole pipeline. So now let's start the implementation. And for that purpose, I have opened the Google Colab. If you want, again, you can also do the implementation in Jupyter Notebook. Whatever is preferable for you, you can do accordingly, right? What I will do is I'll try to change the runtime type to GPU. Okay, it's already been there. If possible for you also, you can also either if you're working with the Jupyter Notebook, use the GPUs which you have in your local system if you do have. And if you don't have GPUs, then it would be great that if you will also shift to the Colab work, right? You can open the Google Colab and you can use the diabetic data with me. And let's see how we can implement the stacking now, all in all. So let me just try to do the connection here. And once the connection will be set up, after that, we will start our further things. Okay, the connection is set up now. Now what I will do is I will try to take the diabetic data. Okay, so I think we have worked on the diabetic data in the logistic regression hands-on implementation. So I'm picking up from there, and let's wait for a while, copy the path, and then maybe we can start writing our code. Now, what we want is, I think the pipeline is clear to everyone. We want to first of all implement two different algorithms. Model M1 belongs to the KNN classifier, and model M2 belongs to the SVC classifier, support vector classifier. So in order to implement that, we have to import those models, right? So let's try to do the import everything in this very first part. So what I will do is, let's do one thing. I will try to import all the required frameworks. Okay? I'll try to import all the required framework. So import pandas as PT, import NumPy as NP, import Seaborn as SNS, import matplotlib dot pyplot as PLT. After that, we will import the two methods, two functions which we want to implement. So from sklearn dot neighbors, NEGHBORS as K nearest classifier, K neighbors classifier. After that, it's not an alias name. I want to import this specific function. to use it, right? Similarly, what I will do is from sklearn.svm, I think we can import the svc also, another method name which we have to use, another model name. So let's import this. And now as a second step, what I will do is I will try to load the entire data set. Now, how can we load? I think it's very easy. Data is equals to pd.read_csv. After that, we will give the path of the data, which I have just now copied few minutes back. And then we can just check the top 5 records available in our data. I think we all are aware about this data. We have an outcome as a target one, and remaining are the input features that we have, right? So what we will do is, in the very first instance per se, let's split the data into, you can say, input features and the target feature. So we have tried to split our data into input and target, or you can say target outcome. So what we can do is we can say x is equals to data dot, we can drop the entire outcome column here. So inside the columns, we can pick up the outcome which I want to drop. After that, I can take the x's as 1 here. And in the y, which is the outcome wala column, we can take directly the outcome column here. So now we will be having x and y available with us. What could be the next step? If you remember, in our stacking part, we need to split the entire data into two subsets. Subset 1, which belongs to the training set, and subset 2, which belongs to the holdout or the validation set. That's what I have explained, right? So let's try to comment it down. So here we have split the data into the input features, input and target features. Now the next step, which is the step number 3, is what we will do is we will try to split the entire data into two subsets, I would say. Two subsets. I think you have seen in the images which few minutes back I have showcased you. Subset 1, which somehow belongs to the train set for now, and then we will be having a subset 2 which belongs to the validation set for now. Validation set, or you can also say it as a holdout set. Make sense? So these are the two subsets which we want to split down in the 50:50 ratio. So split the entire data into two subsets, as in 50:50 ratio. Okay, so let's do that. So what we will do is we will try to have a train set, and then we will be having a, you can say, validation set. So I will call it as val_train. After that, what we will be having is the, you can say, test and the val_test. Done. So we have split our data into these two components, and we can apply a train test split here, and obviously inside that you will be having x, y, and you are saying my test_size is 0.5 because I want to do the distribution in the form of a 50:50 ratio. So that is what we can do. And obviously to implement this, we have to, from sklearn dot model_selection, we need to import train test split. So let's try to run this code so that we will be having now train and test available with us. Now, what is the next step? If you remember, the next step is to further split the data of train and test into two components, right? So what I will do is I will try to take these two components, train and test, and will split my data. So now we will be having x_train, we will be having x_test, y_train, y_test. And again, we are doing a splitting, but now on the basis of the train set that we have generated in the above case and the test set that we have, right? And the test size is 0.2. Means what we are saying is that 20% of data belongs to the test size, right? Random set I am removing for now, and this will be done. So what we are doing here, we are trying to split the train set further into training and test set with a ratio of 80 is to 20, right? This is what we have done. So once this part is done, what we can do is we can now apply a very first classifier, which is the model 1, which we want is k neighbors classifier. So we will do the implementation of k neighbors classifier. Okay. So how can we do that? It's very simple. We can just call this model and we can call k neighbors classifier. And once we call this model, we can fit this model on train set. So what we will do is we will say x underscore train and y underscore train. And once this model is ready, we can also check the score of this model on the test set. So what we can do is give me the score on x underscore test and y underscore test. So we can see somehow the score is approximately 67.5324. If you want, you can also use in all these splitting part one random state parameter, so that at every point of time, whenever you are running your code, you will not see the fluctuation values in terms of the score, and you will be having a similar samples of training and validation part. So for that, if you want, I can take the random state parameter as 355. So we can take random state parameter. You can take anything you can take. And if you want, we can rerun our code again with the same parameter in everything. And then we can again re-verify. So now we are getting a result of 74.025. The advantage of this random set parameter is that in future, let's say if you will run this code again, you will always get the same values, because now the number of samples or the kind of data which is going in the training set and the validation set and further splitting into training and testing set will always be the same, right? That's the beauty about, I would say, this splitting part when we are including this random set parameter. Now let's move ahead. The next task is model 2, where what we are doing is we are doing a implementation of SVC classifier. SVC classifier. Now what we can do, we have SVC which is equals to what we can do here is we can simply call SVC model. One thing which you can observe here is that I'm not doing any hyperparameter tuning. So whatever be the default parameters we have in the documentation, that is what I'm taking it here, right? So now we can just fit our data on top of this train set that we have, x underscore train and y underscore train. And after that, what we can do is we can again check the score of this SVC model, which is model M2, on the test set that we have, y underscore test, right? So now if you can see, the score is almost same, right? What we want is, so until this point of time, our task is done. So what we have done till so far in the implementation, just try to observe it now. We have splitted our data. Diabetic data was there. First of all, we have convert that specific thing into the input features and the target value. So we have split our data into x and y, where x belongs to the input features that we have and y belongs to the target outcome. Now what we have done is, with respect to this given data, which is x, we have splitted our data into training and validation in the form of 50% will go here, 50% will go here. After that, further the split will happen where almost 80% of that train set and 20% of that test set will go there. In this train set, we have fitted our model of KNN and SVC. This is also done. And now we have a score value available for both the models. Until this part, I think everything is pretty much clear to everyone in the pipeline. Now what we will do is we will try to see the predictions. So what we will do here is we will check the predictions of the model in the validation set, because validation set was the unseen set for our model. So what we can do is we will be able to see predict underscore val1, which is the model 1. We can say just give me the prediction for knn dot predict on this val underscore train set that we have, right? Do you remember we have validation of training set and validation of test set? So we can just check the predictions on this train set, and further again we will be able to see for val2, which is nothing but svc.predict, and here again we can take the values of val underscore train. So now here if you will be able to see, we have two things. One is the prediction of the knn classifier, and another one is the prediction of the svc classifier, right, val2. So we have the predictions of both of them, which is knn and svc. What I want is, I want to combine these two predictions, knn as well as svc. So there exists a function in python by the name of column stack. So what I will do is, I will try to combine this prediction, predict underscore val, which indicates that it's a prediction of a validation set. What I will do is, I will use np dot, there is a function called as column stack. So yes, this is the function which I want to use. What this function will do, I am combining the predictions which is given by val1 followed by the predictions which is given by val2. So what will happen now here is that you will be able to see all the predictions are combined together. So here you will be able to see that now, for example, here you will be having a list of two values available. For example, this is the val1 prediction of the outcome, which is 0. Val2, which is svc, says 0. Then here 0 0 1 1 0 0 0 0. Somewhere you can see that knn is saying the prediction as 1, whereas svc is saying the prediction as 0. So there is somewhere clashes are also there, somewhere things are sorted also. So you can clearly see that what is happening is, what I have done is, I have just combined both the predictions of the models. Prediction by the knn classifier also, plus the prediction by the svc classifier in one variable by the name of predict underscore val. Now what we will do in this specific part is, we will simply try to combine these predictions and we will use that as an input parameter. I will showcase you now the concept of stacking. But before that, what we will do is, we will try to see the predictions on the test set also. We have not seen that. So predict underscore test1 by the again knn classifier. So we will say knn.predict, give me the outcome for you can say x underscore test that we have splitted. And similarly we will be having the predict underscore test2, and here also we will be having svc.predict on the top of this testing set that we have. And once this task is done, I will do the same thing. I will try to combine these two predictions by using np dot column underscore stack, and inside that what we can do is, we can combine the predict underscore test1 followed by predict underscore test2. Done. So I think till so far things are sorted. Now we will be having one variable by the name of predict underscore val, which will take the predictions of the validation set that we have, and we have predict underscore test also, which will take the predictions of the test set that we have. I think so far so good. Now what we will do is, we will try to use now the random forest classifier on top of the predictions that we will be having in the validation set. So what we will do is, we will be having one model by the name of random classifier, where I will apply a model of random forest classifier. I think we need to import this model. It's a part of our ensemble technique. So let's import that first of all. From sklearn.ensemble, we can import this model called as random forest classifier. Now I think we can use this model, and this is important to understand. What I'm doing in this stacking is, I'm trying to use the input as the values which is available inside the predict underscore val. Do you remember? So now this predict underscore val is not my original data. It is the predicted data by the knn and svc classifier, right? Do you remember? We have tried to combine these two predictions and we have stored that in under this predict underscore val, and the target is will remain same, which is val underscore test. Now we will fit our model on top of this. So let's use this function of fit on top of this, and that is why it is called as stacking. So this is where the concept of stacking comes into picture. So what is the meaning of stacking? What we are doing here, we are using the here input, you can say features are the predictions of the model M1, which is a KNN, and model M2, which is, you can say, SVC, stored inside the predict underscore val, right? And that is something which we are using as the input features for the random forest classifier. For the random forest classifier. Make sense? So this is what we will do. We will try to wait for some time. Now, once this is done, we can check the score, and our score will be test under rand underscore clf dot predict. Now you will take that predict underscore test that you have followed by the value of y underscore test, right? So now you will check what is the score you will be able to generate finally. Not predict, sorry, I want to check the score. Score. So now you can see that what is the score of your model, and you can see it is approximately same. So this is the overall idea behind stacking, where what we have done here, let me just again go back to the pipeline, which from where we started our discussion. What I have done here in the implementation, I was having the predictions given by KNN and SVC. I have combined these two predictions in the form of a list with the help of a column stack that you have seen, right? After that, once I will be having these predictions, I have used these as the input features, right? My target outcome will remain the same, but these are the input features of the random forest classifier. And finally, I will be able to get the predictions, and I will be able to get the score. I hope that it makes sense to everyone. Now, what I was showcasing you in the pipeline, and now because I have shown you the implementation for the same, now I think things will be far, far easier for you. One more thing which we can do here is we can do the hyperparameter tuning to check the optimal parameters for the random forest classifier. Maybe you can apply the concept of grid search CV by passing all the optimal parameters. So what I can do is maybe I will try to generate this grid param. I'm not sure that which particular estimator I can choose. So I have just mentioned this one. And once you will run this code, you can just simply apply this function name by the name of grid search CV. Obviously, to apply this, you have to import these specific functions. So I think from sklearn dot where it is available, let me just grid check the documentation, search grid search CV. It's a part of a hyperparameter tuning, so it should be available in model underscore selection. From sklearn dot model underscore selection, we can just import this model first by the name of grid search CV, and then maybe we can just use that. Maybe I can use this here itself, and now we can call this method, right? So once this will be done, we can just fit this data on top of our values that we have, which is nothing but you can say predict underscore val and val underscore test, right? So this basically fitting will provide me the optimal parameters, and after that we can just try to check it out that what is the best parameters that we have by mentioning this best underscore params underscore parameter. So whatever be the best parameters is given by the model, what we can do is we can retrain our model of this random forest by mentioning the parameters which is given by my model, right? So I hope you all know that how this hyperparameter tuning will be done. So what you can do is after the fitting part will be over, you can retrain your model again by using the best parameters which you will be able to get in the previous cell. And once that task will be done, you can again try to check out the score, right? So you can again check out the score of this part, and you can just verify that whether the score is improved or not, right? Maybe you can just rename it as after hyperparameter tuning, hyperparameter tuning, so that we will be able to get an idea that, okay, these are the parameters which we are choosing as per the hyperparameters. So you will be able to get the score for the same, and then you can just verify that whether the score is approximately similar or not. Now, this fitting part will take a lot of time, and maybe I will try to post this video for now. And whenever I will be able to get the result, I will again shoot the video with respect to the result which I am getting. And then you can just verify that the results and then the best parameter and the score, whether we are getting the similar thing or not. So this is the overall idea behind the concept of stacking. So meanwhile it is running, I'm just giving you a brief recap of what we have done here. If you will, if you have seen here what we have tried to convey, we have tried to first of all import all the required frameworks. After that, we have loaded our entire data. We have tried to split the data into training and the target value that we have. Then the very first thing is we have tried to split the data into two subsets. Subset one, which is a training set, subset two, which is a validation set. It's a set which is not viewed by the training model, right? That is where we will be able to get the actual predictions that how our model is behaving. After that, we have further split our data into training and testing in the 80:20 ratio. We have used two models here in our pipeline. One is KNN, another one is SVC. Then we have combined these predictions on top of whatever be the validation train set that we have. After that, we have also used and combined the predictions of the testing set also. Then we have trained on top of the, you can say, base model, the random forest classifier. Always remember in stacking the upcoming model that you have. For example, in our case, it's a random forest classifier. The input was the predictions given by the base model. That's why we have taken predict underscore val as the input feature, and the target is val underscore test. We have seen the score for that. And now, just to optimize our result more, we are just using this hyperparameter tuning. We have already discussed about this a lot in the previous sessions, that how this hyperparameter tuning is being done. You can do it at your end. Maybe I'll just I think we can just stop this video over here itself. I will share this file once the video will be, once this file will run properly, right? And you can just verify the results, that how the results are going up. But this is how basically the things will work in the stacking part per se. I hope that the implementation of stacking is pretty much clear to everyone. Whatever doubts if you have, you can just ask from me, you can just reach out to me. One important thing is, just like the previous models which we are doing as an implementation, we are directly using this sklearn, right? When we are doing an implementation of grid search CV or randomized search CV or k nearest neighbors or SVC, we are taking a help of sklearn. In stacking, you will be able to observe we don't have as such documentation from where you can just import the stacking algorithm. You have to just make this pipeline just like the way I have done. Even you can refer, as I always say, a standard book by the name of Hands On with Machine Learning. You can see the stacking page on that book, and whatever they have mentioned, you can just verify. Now, I think after watching this video, things will be very much easy for you to understand. Okay, this ran properly. Oh, superb. So let's try to run this and just check it out now itself, that what are the values we are able to get here. Criteria is Guinea. I think by default in a random forest classifier, the criteria is Guinea only. So there is no need to change that part. After that, they are saying that maximum features is auto. So it is auto only. Minimum sample sleeve is 1, they are saying. Minimum sample sleeve is 1. It is by default only. Minimum sample split is 4, they are saying. Usually it is 2. So let's make that parameter as the important one. So I'm taking this parameter of min underscore sample split as 1 in my case. So this is 1 I'm taking. So what I'm doing is, whatever be the default parameters I have, I will not change that. Whatever be the changed values we have, number of estimators they are using as 90, they are saying. So let's work for 90 itself, right? So let's work for the 90 itself. The best parameters given by the grid search CV. So let's try to retrain our model on top of this part. Okay, we have not fitted our model. Let's try to first of all fit the model on the predict val and val underscore test. So let's try to fit on top of this, and then we will check must be an int in the range from 2 min underscore samples underscore split. Oh, it is 4. Sorry, I have mentioned it wrongly. It is 4. So let's rechange it. Now it is working fine. And now we can just verify the score value further again on the test part per se. So we can just take this as the parameters to verify. And let's see. It is not as such improvise the results, but I feel that if you will just do the proper EDA of the file, just like the way we have done in our previous discussions in the logistic regression module. And if you will take the updated file, maybe you will be able to see the results variation, right? But for now, I think in terms of knowledge per se, I think the things are sorted. I have done end-to-end implementation and showcased you that how basically the concept of stacking internally works. So now I hope that the complete intuition behind stacking is pretty much clear to everyone. If you still have any sort of doubts, any sort of confusion, please do reach out to me. You can reach out to me via my email, or you can just search my name on LinkedIn, and easily you will be able to get that. And you can send me the request, and I'll definitely see your text, whatever you have queries, right? With this, let's end the today's session. I will see you all in the upcoming video, where now our focus is on next type of ensemble technique, which is boosting. So we will talk about three different algorithms in boosting. One is EDA boost, another one is you will see XG boost, and the last one is gradient boosting. So all of these three we will discuss in a lot more detail with its implementation. So please stay tuned, and I'll see you all in the upcoming session. Bye bye, everyone, and see you.